also with us Professor Raj Ramasankaran, who is a professor at IIT Mumbai, and he leads the Hydro Remote Sensing Applications Group at the Department of Civil Engineering at IIT Mumbai. And through his work, he basically focuses on the use of GNSS and aerial remote sensing measurements to study different aspects of the water cycle. His group is also involved in working with urban remote sensing to understand landscape changes. And I think one of his students will also be presenting in the youth section tomorrow on this particular aspect. He also has numerous publications and awards to his credit. We'll share the link to his CV so you could have a look at his profile as well. So without much ado, since we are running short on time, I would request you to take charge of the session and make your opening remarks. Thank you.
Right, sir. Good afternoon, everyone. I hope I am audible.
Yes.
Thank you. All the participants, the expert present here, I extend my heartiest welcome to all of you for this last session. Let me share with you that this session may be the third for today, but this is probably the most important session. If you know the IGIF framework, in the IGIF framework, there are three pillars, and one of the most important pillar is the people. And in the people pillar, there are three different pathways, and the most important pathway is probably the capacity building and the education. Whether it is governance or whether it is the industry or any other application, everywhere you need the capacity and the education. Now the objective of this pathway is to raise awareness, build and strengthen knowledge, competencies, skills, instincts, processes, and whatnot. There are four elements of this pathway: the awareness, the formal education, the professional training, and the entrepreneurship. I will not go into the details of them. Those who are interested can always visit the UNGGIM site and have a look at this particular pathway and the complete structure of this particular pathway. Now, without wasting any further time, I would request Professor Raj Krishna also to say a few words, and then we can start with the session per se. Dr. Raj Krishna.
Yeah, thank you all for introducing me, and I'll welcome all the participants also for their presentation. So since I think we are already late in starting our session, and we have 7 presentations, so I request the participants to restrict your presentation to maximum of 12 minutes. So we will have the discussions at the end of the session. So now I will request Professor Tiwari to start the session by inviting the first presenter.
Right. So the first presentation is by Dr. Seema Jalan. It is on the topic of electoral information systems for governance and development planning. Dr. Seema Jalan, please start. And I would request you to highlight the aspects which are relevant to the from the UNGWIC this thing, and so that we can restrict our discussion and this discussion and the presentation focused, and we can quickly finish off. Although time is not a restriction because we are last, so we have all the time. So we can have a detailed discussion at the end of that. Dr. Seema Jalan.
Yeah. Thank you so much, Dr. Tiwari. I'll just share my screen. Is my presentation visible?
Yes, ma'am. Yes, yes.
Okay. Thank you, Dr. Tiwari, and thank you for being so generous with the time, but I'll try to wind up within the given time only. This is actually a major research project which is presently being carried out by us under the RUSA, the Rashtriya Uchchatar Shiksha Abhiyan scheme, which has been funded by MHRD. And it is a Geo web portal that we are developing, which is titled as Electoral Information System for Governance and Development Planning, particularly with reference to the state of Rajasthan. And it is a, you can say, a novel pilot application we have developed as a G-governance initiative. It is a collaborative research project, and the Department of Geography, Mohanlal Sukhadia University, along with Dr. Shailesh Chaure, who's a WebGIS expert from Government Holkar Science College in Indore. We are doing this project. So if we talk about the UN Sustainable Development Goals, we particularly focus on the goal number 16, particularly 16.6, which says that, which mandates to develop effective, accountable and transparent institutions at all levels, meaning thereby that the institutional mechanism should be such that the entire government expenditure should be so channelized that it meets the people's needs and expectations. So this web portal is basically, it touches upon the first 5 of the first 6 goals, that is no poverty with particular reference to the social security schemes, zero hunger with particular reference to the food security, good health and well-being with particular reference to the health infrastructure and services, and quality education with particular reference to the education infrastructure at grassroots level, and availability and accessibility to clean water and sanitation facilities. Whatever we, in fact, cutting across all the sustainable development goals, the main requirement is reliable spatiostratal data, which is the key to decision making, whether it be any department or any policy per se. And technology is the only way out, which is, I think, what we've been talking about since morning. The main question is whether we talk about any kind of application, any kind of policy initiative, the first thing is whatever phenomena we are talking about, what it is, basically what is its status, present status, and across space and time. We are concerned about the deprivations, we are concerned about the regions which are lagging behind, the patterns and disparities, that is what is where. Then we come to the intensity of the problem, how much intense is the problem, what is the depth, what is the dimensionality, what is the intensity. Then we want to understand the reasons behind the occurrence of a particular phenomena in a place, a particular kind of deprivation. So we are concerned with the relationships and theorization, and we also want to understand, it is very, very important to understand the trends also, how long situation has been like that, and what are the solutions which should be actually designed to improve the situation. So we need all the policy makers, whatever interventions are designed and implemented, and to ensure that they reach the beneficiaries, the issues to be addressed are identification of the problem, measurement of relevant phenomena. We need reliable data, we need to map it, analyze it, monitor it, update it, and particularly in the governance, it is extremely necessary to plug in and identify the leakages first and plug them in. Transparency in delivery is very, very essential, and integration. I have highlighted this aspect because one of the major observations, I think everybody will agree, is an integrated solution which is actually pans across the departments. We see that mostly there's a lack of coordination between different departments, so integration is very, very important. We need to have a transparent feedback mechanism also to understand the efficacy of the solutions which have been implemented, and we also need trained human resources, that is capacity building is also very, very important. So in this broader framework of the SDGs, what is most essential is direct access to information for all the decision-making authorities. But one of the biggest hurdles for effective governance, particularly in India, that we observe is lack of information only in an integrated environment. Mostly we observe that in different schemes schemes that are being implemented, there is lack of coordination between the related departments, the efforts are not synchronized, and mostly the information is not shared across the department. So we need the holistic approach in planning and implementation is lacking. And the result is segregated planning, and the implementation is not very planned, and mostly at times it is haphazard. The use of resources, particularly the financial resources, is at times injudicious, and despite of all the efforts, we observe that there is a status quo, and despite of huge allocation and expenditure of the national financial capital. Therefore, access to high quality, accessible, timely, reliable baseline data is very much needed, and that is a huge challenge for decision makers. So basically, what we focus on in our portal is, if this baseline data is available to the decision makers, these decision makers may be the people who are sitting in the executive in the government, or the people who are a part of the legislature in the government. If this baseline data is made available to them, which has been measured in an objective manner, which can also provide them the present status of the various phenomena in their respective areas, which can help them monitor and also ascertain the progress in a particular field, then perhaps they can be more nearer to the targets. Here we, actually being social scientists, we approach this problem with a political economic perspective. And as we all know that India has a democratic system of government, which is actually first past the post single member pluralistic democratic representative system. Why is it so important? Because here there is a cutthroat competition between the various people who contest for the legislature, and even one vote makes a difference. Therefore, and ultimately it is the government, we can say that the geography of welfare, economic development and social justice, that is who will get what, in how much quantity and where. All this is very much determined by the government policies and the priorities of the people who are there for their, we can say, sitting in the legislative bodies. And the political economists, a host of studies, they have advocated that the government decision making in a democratic system, it involves striking a balance between their economic, we can say, the development objectives and their political objectives, like running for the re-election. So while ensuring their all own survival, that is, the people who are decision makers, they want to achieve the development targets, but at the same time, they also want to ensure that when they run again for the elections, then their prospects of success should be higher. So we cannot say that development is not related to elections or politics, or social well-being is not related to elections or politics, but it is a very intricately balanced triad where all these affect each other. So this web portal that we are talking about targets the legislators, the executive and the stakeholders, that is the common people. And it is an effort to bridge the gap between the political and welfare objectives of legislature. It is a novel WebGIS application which explores the integration of multifarious types of cross-departmental information in a geospatial environment in an interactive and dynamic manner. So we want to enable the legislators to have a very sound understanding of their support base, the pattern and trends of their support at all the three levels of elections, the local government elections and the Vidhan Sabha and the Lok Sabha as well. At the same time, we also want to enable them to have ready access to the grassroots level socio-economic demographic characteristics, all the development issues of their regions, and they are also able to visualize in a spatial context in an integrated geospatial environment, so that they can take informed decisions and they can work for redressal of the problems, and which will ultimately, as we actually want, that it should result in increased efficiency, accountability and transparency in governance in a citizen-centric developmental planning. And for this, we have conducted an intensive field survey. So basically, the web portal has two phases. The phase 1 is the state election GIS for the state of Rajasthan, and it is a comprehensive electoral statistics at an assembly constituency level for the entire state. The database has been created for all the post delimitation elections post 2008. And the basic purpose is, first of all, to aid the state election department in conduct of the elections and a better election management. And secondly, also to inform the stakeholder political fraternity of the spatial patterns of all the related electoral phenomena. Then we have phase 2, which is focused on one particular Vidhan Sabha constituency, Tonk Vidhan Sabha constituency in Rajasthan. Here we are developing it into like a G-governance application for developmental planning. And here we have given the booth level election statistics of urban local body and panchayat elections. So all the legislative, like the representatives, they have, for each particular booth, they have entire election information right from the local government to the Lok Sabha elections, and also they have the grassroots level knowledge of the issues and the developmental problems and other characteristics of that particular region. So this is the this portal is just under development. A part of it has been completed. This is a glimpse of the home page. As you can see here in this page, we have the results at the state level and for single constituencies, whether it be Lok Sabha or Assembly. So if we select any particular constituency, we can see all the results here. All this information, different types of relevant information is there for each constituency and the entire state as well. Here we have selected a particular Lok Sabha constituency and all the information regarding all the how many polling booths were there, which party won by what margin, and top 5 parties, which, and everything, all the information this can be seen here. Here for an assembly constituency, similarly, all the patterns and everything, all the results can be visualized for all the Lok Sabha, all the assembly elections. So we have actually given a face to the vast amount of election statistics which is being generated by the election department, and now it can be visualized. Not only for governance, it can be extremely useful for academia also. Then this is the page 2, where we have there is data exploration and visualization tools we have, which are useful for academia, election management, and the contesting stakeholders as well. And all the things can be visualized and on the some base maps which we have given here. And for any kind of attribute, we can see all the patterns and all the relevant data across the constituencies at for Lok Sabha as well as assembly elections. Here we have another utility in the next page, where the maps can be queried, they can be visualized with using a flexible classification scheme. Queries can be designed, and all types of interactive visualization and data exploration capabilities we have given here. All these maps can also be printed and they can be downloaded. Here, as we have shown that a small query has been run if election department wants to know that which are the constituencies where more critical polling booths are there, then they can run a query. And these are very, very simple. Any person with minimum level of technical knowledge, they can perform all these queries and get the results. Here on the next page, we have also given some tools where the different patterns and trends can be visualized in form of different diagrams, and all these can be printed also, and reports can be generated from here. Again, here we have shown some results which are there on a portal, and we have around 25 to 30 attributes which can be queried and visualized here. The next page gives a comparison across different elections. So if there's some attribute that any stakeholder wants to compare across different elections across time, so they can be generated here and they can be compared. Here we also plan to give some important links and contact information which may be relevant to different stakeholders. It is still under development. So for the synchronized maps, we have all these are some of the attributes which we have given for these synchronized mapping. Now coming to the phase 2, the Tonk Assembly Constituency GIS, this is the main G-governance application where we have taken a lot of variables relating to the demography, the socio-economic composition of the population, census attributes, law and order, physical landscape, resource-based infrastructure, amenities, local. All these are based on intensive field survey that we have conducted in the Vidhan Sabha. All we have talked to the people and identified the local issues and problems that they are facing, what are their demands for development, and also the demands which may affect their electoral choices. Then we have detailed polling booth level results for the local government, the Vidhan Sabha, as well as the Lok Sabha elections, and all those have been put on the portal. So this is the Tonk GIS wireframe that is presently under development. And as we said, we have all the infrastructural facilities and all the information which is we plan to put on the portal. And these are the layers in the Tonk GIS framework. We have some base maps so that the information can be visualized in the context of in spatial context. We have all the boundaries starting from the ward boundary, village boundary, block boundary to village and assembly constituency boundary, ILRCs, patwar circles, all the boundaries are there. We have a lot of infrastructure data which we have collected using the GPS survey, and a lot of thematic layers are also being hosted, including the land use, land cover, master plan, road network, and all this. These are some of the attributes that we have hosted on the portal. They are related to the agricultural infrastructure, the community facilities, education infrastructure, financial infrastructure, the government offices which are there, the health infrastructure at all levels, the law and order, the police stations, the thanas, chowkis, everything, and also the transport infrastructure we have hosted on the portal. We plan to give the visualization as well as the query facilities on the portal, so that for every village or at polling booth level or panchayat level or a ward level, if they want, if the decision maker, whether it be a government official or may it be the elected representative, may it be the local government or it may be the Vidhayak, if they want to interact with the maps and they want to identify the problems, then they can run simple queries and they can identify what are the local level, grassroots level development issues at any in any region. And here they can also explore their area, because at times the Vidhan Sabhas or the constituencies are so large that they don't know which ward is there, which village is in which panchayat, and a lot of information. Actually, all these have come out of some interactions with all the stakeholder departments and the people. So whatever kind of queries that may arise in their minds while they plan some kind of a development scheme or any kind of action, then we have tried to incorporate all that in this, those facilities in this. These are some glimpses of the data which we are going to host for the Tonk GIS. This is the master plan of Tonk municipal area, the land cover of the entire constituency.
This is again a research project funded under Spatial Urban Governance from DSG, 3D City GML Building Modeling from LiDAR Point Cloud Data. Thank you, Dr. Shamita, for having me over here today. So this is...
Ramya, maybe you can make it in slideshow mode.
Yeah, sure.
Yeah.
Okay. So this is the overview of the talk. So I'm going to talk on what is City GML and what is why is it needed, and brief on urban information modeling and how we can derive the City GML from LiDAR point cloud data. And I'll discuss about the case study that we have carried out in Thiruvananthapuram and its application to flood modeling. So yes. So now with our recent government initiative on smart city mission, high precise 3D virtual models are in demand. So digital twin models are in demand for managing and monitoring the smart city infrastructure. So this will enable decision makers for making informed scientific decisions for sustainable management and monitoring of the growing cities. So these 3D city models will be able to provide additional information that a 2D model, 2D map will be able to provide. So for example, if I have to do certain queries like what is the solar potential of the building based on the geometry of the roof, as one of our earlier talks was on, or how many floors of the building will get inundated if a flood occurs. So these kind of queries would not be able to answer with a 2D map. So we would be requiring 3D models for those aspects. So these 3D city, however, like when I have a 3D pure geometric model, it will have no useful information for for helping me to query such a thing. So in this aspect, so apart from the 3D model, I need to integrate some spatial and thematic property. So that is actually a key to have a urban information modeling system. So so in this aspect, we have the city GML. So city GML is basically a OGC standard. OGC is basically Open Geospatial Consortium standard that enables storage and exchange of 3D models, and these 3D models will be can cater to different application domains. So the 3D models are it can be categorized based upon the level of accuracy at which we are producing, as LOD1, LOD0, LOD1 up to LOD4. So the more the detail we have, we go up in the level of detail. So here, so the main thing about the city model is it can integrate the semantic information, semantic and the thematic information along with the geometric information. So for example, here I can say this is a building, this is a roof of the building, this is the wall of the building, and this building is meant for residential. So it's not just a pure 3D model, rather it will have some semantic information to it. So that is the beauty of having a city GML model. And when I have a city GML model of the buildings in the city, then it can cater to answering many questions related to geospatial problem. And there have been many studies on using this city models for different applications, from urban planning to disaster. So I am going to concentrate on sustainable SDG goal 11, which is making cities and human settlement inclusive, safety and sustainable. So here in this aspect, so we need to have a 3D data. So LiDAR is found to be one of the most unprecedented geospatial technique for direct and accurate measurement of elevation of Earth's surface, which can be directly used for creating 3D models. So integrating three important technologies, that is laser ranging, IMU and GPS, LiDAR produce dense georeference LiDAR point cloud. So it makes a precise elevation measurement of over a larger area. So this is a simple example of a LiDAR data. However, there is quite a lot of challenges in processing the LiDAR data. So it is very unstructured, massive, and it is very computationally demanding. And the processing technique that we need to apply on this 3D data is quite different from what we do it from a 2D data. So in this aspect, so for creating a city GML model, we have followed certain methodology. First thing, given a LiDAR data, which is just a XYZ point, first I have to isolate the building. So all this we have created using an open source platform. We have not used any commercial softwares for doing all this work. So we have developed using our own algorithms and things. So from the LiDAR point cloud, I have to first isolate the buildings and then use it for creating my 3D model. So this is basically an overall view of the methodology that we have adopted. So recently, as a part of the DST funded project, we have captured over 100 square kilometers of the Trivandrum city along with some ground truth data. So now, as I told, the first step is to label or classify the data. So in that aspect, we have developed our own approach, which is superoxal based spatio-semantic approach for labeling the data, which uses object-based classification framework on the 3D to label each and every point in the point cloud. So apart from that, we have also worked with some deep learning architectures such as PointNet++, and RAND-LANet architectures, which are used to label the data. So with this, we have labeled this LiDAR data. So as you can see, the LiDAR data of India and Kerala especially is quite very complex, in the sense in Kerala, if we see, or in Trivandrum, most of the houses are surrounded by thick vegetation. So our algorithms have proved to work for detecting the buildings even which are within the vegetation cover. And so now that is the first step. So we have overlaid the data, the classified data over the orthophoto, and we have got a very interesting and very positive results. This is just the visualization. So once the buildings are classified, then once all the points are classified into different categories, we have classified into 8 categories. We have isolated only the building points, and from those building points, again, we have used some instance segmentation approaches to isolate each and every building. So from that, we have created this building footprint. So all these are automated procedures that we have adopted. So once that is done, these buildings are then used to create the CityGML model. So as I had told, these are not just 3D models, just elevated or extruded. These models have these information. So here what we have done is we have included some GIS layers. So one of the things, so this is an ongoing project. So here we have included the ward name, ward number, etc. onto my 3D model. So this we have portrayed it in the CCM open platform. So the plan is to release it as a web-based interface so that decision maker can use it for querying and stuff. So here we have integrated the ward details to each of the building, and also like here you can see that we have classified the buildings based upon the height. So this is an important aspect because our aim is to, one of the applications that we are trying to demonstrate is to see how the flooding over the 2 main rivers in Trivandrum, just the Karamana River and Pilli River, is going to affect the how the flooding is going to affect the buildings nearby. So in this aspect, so this is something that we have done in this web-based platform. So we can, this is the initial work, still more work is yet to be done. So we have classified the building, we have categorized into official, residential, retail, and public and category. And then we have used Hecra's flood modeling software to create the flood modeling scenario. And then we have integrated with the with the building terrain. And so this is going to be, so more layers would be finally added later, and not only the ward and the ward details, but other GIS information would also be added, so that it would be, it would create an interactive display for the policy makers or decision makers to use the data. So more, the future work is more GIS data needs to be integrated, and we are also planning to create a LOD2 based model. And another one of the important thing that we are working on is creating a building information of few models and then integrating with AR and VR kind of application. And then apart from this flood modeling, we are planning to expand it to different application domains. So
the GIC, can we go to the next slide, please? So just to give you a background, GIC lab in IIT Bombay has been existing for a good number of years, since 2009, and the next, if we can please. So we have been doing a lot of activities in the lab. As a part of the computer science department, we had workshop, an international workshop way back in 2009 itself, and then we had a OGC TC meeting. We recently published a book in which Dr. Shamita Kumar has also contributed a chapter. And we have been doing our bit in the development of geospatial technology, mostly on the computational part, but we have realized that geospatial technology or geospatial information sciences, as we know it, is way more than just computational, and it is a truly interdisciplinary engineering practice, as we may say it. And we were also invited to come to a meeting in Hyderabad where we discussed the need. If you could click again, we organized a workshop in the COMAD workshop in Hyderabad just before COVID hit. And there we came to the understanding that there is a scope for developing a hub, a geospatial hub, and that all the researchers need to understand the requirement of a multidisciplinary effort. And we were asked by the Secretary of Department of Science and Technology to expand our activities. We click next, his letter to IIT Bombay to develop a proposal to generate a GIC, Geospatial Information Science and Engineering Hub, as a hub and spoke model to further the vision of having a national center of excellence and developing more such hubs. We call it the hub and spoke model, but you can think of it as more as a hub and mini hub model, where at the end of the 5 years, we are able to nurture many more hubs that will go on to have their own hub and spoke model. So next slide, please. So the objectives of the GIC hub are very important to understand. We are not looking for only multidisciplinary research. We want to foster application of geospatial sciences to work with specific sectors such as irrigation, public transport, through engagement with regional, state agencies. Of course, the central government, we are a central government funded body, but we also work with regional and state agencies. We are looking to making sure that the community, the agencies that fund these projects, or they are engaged with us in such projects, also develop their capacity to use the outputs of the project. And we also want to provide educational outreach under strategic partnership. We will see how these few points, and we can click the last point also comes up. We also want to have the data for policy initiative under the Geospatial Information Science Engineering Hub, where governance and policy making benefit from the technology. And finally, we also want to provide support for innovation through support for entrepreneurship in geospatial technology. And we are joined with multiple industry and startups in this area. And finally, the last one is the FOSS. If we can go to the last point on this slide. Developers and support the FOSS software development, free and open software development, data sharing, and facilitate open source community discussion for geospatial information in India. So these multiple objectives that you see are very well thought out objectives that the logic behind this these objectives is what is the focus of my presentation. If you go to the next slide, please. So it is in some way a unique approach, and what we are looking is to create a holistic approach to enable functioning multidisciplinary hub and spoke model. The hub and spoke is also within the institution of IIT Bombay, where we will have the hub facilitating multiple projects in geospatial technology, and also across outside of IIT, across institutions to facilitate such research in collaborative mode. We are also looking at developing strategic partnerships for capacity building while we do such projects, and combining research with outreach. I will revisit these points a little later in my presentation, but we also want to combine FOSS, free open software, free and open source software, with the availability of open data. For example, much of FOSS development around the world has been in partnership with availability of open data, which that we don't see in India so much today. For example, we have Bhuvan as data that people can access, but you are dependent on multiple ways to access that data. So the integration with FOSS and open data, and also looking from analysis-ready data to decision-ready information. That's the chain of projects that we are looking at. We are also looking to combine geographic information sciences with engineering. So we will examine what that means in the context of geospatial technology in a few slides later. And we also want to add entrepreneurship to innovation. So in some sense, as Deepriya would mention earlier when we were discussing about this, our approach is very much in line with the 9 strategic areas that UNGGI, in its first meeting and thereafter has been discussing, that every member state should make progress on. So we hope to show some progress in all these strategic areas, including governance and institution, data, partnership, capacity building, innovation, standards, communication and engagement, and in some sense also the financial. So that my talk outline is basically these. I think we can go to the next slide. So I'm going to speak a little bit about geospatial technology paradigm shift that we can see, and why this is important in the context of engagement with communities, so that we partner with them to make best use of these new opportunities. We heard about 3D LiDAR in the previous talk and digital twins. We will see why that is important. There's 5G that is coming up, the next generation Earth observation. We will speak about large scale application. We are already familiar with Google Earth and Amazon and also Bing, the Microsoft Bing platform. So the huge platforms that we have and the large scale applications, how we can best use those. Then we have the mention of spatial big data and geo AI. So all these paradigm shifts, I think, provides us an opportunity to leap forward. Societal challenges at the same time are also very immense right now, and we will see that climate change, pressures of urbanization, resource battles that we see, they can be I don't know if they can be solved, but they can be addressed in many ways by the new opportunities in geospatial technology. There's human opportunities in terms of enabling spatial thinking and enabling geospatial engineering, which in turn provide job opportunities and opportunities for entrepreneurship. We go to the next slide, please. So as I was just beginning, the state of art has changed. It has changed so much that many of us who are so much familiar with the images on the left side, that's the typical desktop GIS, data and layers of information. And on the right-hand side, what you see is actually a HD map, high density map. And this is LiDAR point clouds, classified LiDAR point clouds that are typically used by autonomous driving vehicles. So the point I'm trying to make is there is tremendous change, and the conventional ways of working with geospatial data have kind of, I wouldn't say disappeared, but have taken the back seat, and there's immense technology potential that is coming up in terms of LiDAR, 3D data, and digital twins that we can kind of leverage. Let's go to the next slide. But it is not GIS anymore, in the sense that these are not just systems. These are, geospatial technology has gone beyond the typical systems approach, and many opportunities exist in terms of coupling the natural systems with human systems. So while you have the physical geography, the earth observation, then you have the human activities in natural spaces. And this opportunity is not only immense, it's also proving to be very critical. We have seen in the recent days when in the recent years, and again as COVID numbers are mounting, how geospatial technology helps us define our human systems in the situation of challenges such as COVID lockdowns. And what you see in the center is a 3D map of Mumbai, which was of South Mumbai, to be more precise, which was created as a POC. And I know that many academics have now got access to this data to play around. So this is not conventional GIS. To load that data, you need a specific special, let's say, systems which are not typically considered as GIS, and where we can analyze this data, present this data, and use. So we saw the flood modeling. We can do things that were not previously possible. Let's go to the next slide, please. So I don't know if you are aware, many of us are not. There are NCERT textbooks on geospatial technology that have been in existence for almost 10 years, more than 10 years now. And if you see the point cloud of when like 10 years ago, these were the kind of things that you had in the point cloud of a typical subject or a web page speaking about geospatial technology. Whereas what you see now in the times of big data, big spatial data, you see the point cloud has changed. So this transition is important, and I want to make the case that when we make this transition, we have to be careful to ensure that we take a pragmatic and practical approach. So this is what we are trying to see. Can you go to the next slide, please? So a lot of discussion. I think many of us have been a part of the Digital Earth project since the time of Al Gore and climate change, and the discussion of sustainable development. But the more important thing to consider is there are topics that are global to local, in the sense that these are global challenges that need to be fought at the local level. So, for example, tackling the global effects of climate change. So you need to have the big picture. Yes.
Can you conclude within another 3 to 4 minutes?
I'll try to do that. So, whereas we also have the local to global aspect, where we have requirements such as providing communities for participatory planning and governance. So the point is, can we go to the next slide, please? So while we go to the next slide, let me mention that in the Geospatial Information Science and Engineering Lab, we have multiple projects already being taken up. Can we go to the next slide, please, Sam? Two of the projects that I will discuss. One is about project of climate resilient agriculture, or POCRA. And can we go to the next slide, please? Okay, so you can see more details about that project, but it speaks about challenges solving the climate change problems at the local level. Can we go to the next one, please? And this is about a disaster management stack, where we are trying to provide geospatial technology application applications across the disaster management, applications and data across the disaster management cycle. And this is more from the local to global level. Can we go to the next slide, please? So those are just few projects that we are looking and we're taking up at the Geospatial Hub, GIC Hub. We are also seizing the opportunity with the new geospatial data policy and expanding the geospatial marketplace. We want to increase our capacity to use technology to solve problems, learn and adapt technology, create avenues for jobs and entrepreneurship. Of course, create technology, but also create technology leadership. We know that more than 20% CAGR growth is expected in the geospatial marketplace, but sustainability of this growth is very key. So can we go to the next slide, please? These are some trends. I'm not going to read out because but the idea that there are some trends in geospatial technology that are driven by different factors, and we will leverage these factors so that we can make best use. Can we go to the next slide, please? So this is the most important slide that I have, and this is borrowing from the work of Tom Carlson and a discussion I also had with Karen Kemp and a lot of people during the lockdown about pedagogies for resilient GIS science education. And so the important thing, as we said, this is a renaissance era for mapping. And there is an important opportunity for transdisciplinary learning. Now, this is only possible by learning in the field. Tom Carlson showed how learning on the field is so important for getting, all the concepts, the pedagogical elements of learning and geospatial technology. And some of the salient points, if you see in marked as bullets here, shows how real application and starting, problem solving approaches are very essential to developing the capacity that we were talking about. Can we go to the next slide, please? So this is again borrowed from some of the work done by Shashi Shekhar and the Association of American Geographers, that we have to develop the spatial computing thinking and spatial computing side by side. We go to the next slide, please. So geographic information science meets geographic information engineering, and that, if you see in the Venn diagram, provides you the avenues for growth of each of these and the overlap of what we call as technology, which has overlaps with both science and engineering, and that special area of overlap of all the three is where we would like a bigger expansion. Can we go to the next one, please? So these are some of the steps forward that we have decided for ourselves. And as you can see, this is coming from the same point of view, that from applications, we want to move to solutions. We want to move from development of geospatial technology to engineering of that, project-based learning and learning while building, open data for experimentation, considering the life cycle, the FAIR principles, and also looking at multidisciplinary efforts as a mandatory requirement. Can we go to the next slide, please? So again, revisiting the GIC Hub approach, we have all the 6 points that we had put up earlier, and we speak about hub and spoke model as teamwork and sustainability by developing technology stacks, working to enable technology, geospatial technology stacks. Can we go to the next slide, please? So I will just conclude and let we hear more questions in the Q&A after the other talk. Thank you.
We try to do what's try to apply geospatial technology and also educate the stakeholders regarding the biodiversity aspect. Now, this particular biodiversity aspect we could get from the kind of a work we did. And basically, it is the ODK Open Data Collect, Open Data Kit. This is the application which we have used. And using this particular application, in fact, we have gone for application of this particular application in several projects. The very first project was being a committee member of District Raigad District Wetland Committee, Brief Documentation Committee. For the first time, we applied this particular ODK technique and then bringing the results to basically the open source software, that is QGIS. So what we could do is, what we could achieve was basically the floodlight demarcation. And as everyone knows that whenever it comes to high flood line demarcation, it is the month of August that is generally used. And whenever we talk about the satellite data, a very clear satellite data is not available when it comes to, of course, we have several now banks with which we can do that. But then for a layman, for researchers and for common people like us, it is very difficult to have access to this very high-end technological data. And that is the reason what we did was we used basically this open data kit, that is the mobile collect application. And here you can see we have basically emerged with a high flood line, and then you will find that 75-meter buffer of no development zone. Additionally, what we could do was we actually went on collecting the point locations, and these point locations were of the trees. When we collected the point locations, it was difficult for us to run the spatial query. And here you will find that the trunk size and other things, we could basically run the query on that, and we could emerge with a kind of a distribution, spatial distribution of various trees having, say, trunk size more than 100, you can say, centimeter. Here we could also locate a specific variety of flora, and that is Cates sour. This is the local name of the tree, and we could locate this. On the basis of this, we also could move forward, and we could also emerge with a kind of a habitat mapping. So it is the insect territory. As you know that there is a definite relationship between the existence occurrence of flora and fauna, it's correlated. And so we could basically go for that. Now, taking basically clue from this, and that is basically the importance of habitat mapping, which is very much necessary for wetland safeguarding and conservation. Of course, climate change and wetlands are very closely associated. What we did was we extended this particular effort and we converted this into education for sustainable development, and how basically we can convert the university campus into green campus, and how we can initiate a climate action. At the same time, how we can basically integrate this climate action into quality education. And then this is how we went further for introducing one specific, you can say, program, and that is basically My University, My Campus, It's My Responsibility. That is a slogan, and it is the Green Campus Initiative through participatory approach and innovative practices. So enhancing biodiversity, because it is Mumbai, the top city of the country, so sustainable cities and communities goal 11, and hence, what we did was we actually went for a kind of an interdepartmental initiative. It was an initiative under National Science Day celebration 2021. And then what we could achieve was, it was the relevance of this particular exercise was urban resilience, livability and sustainability. The effort was interdepartmental, interinstitutional, because it was sent, you can say, St. Xavier's, that also emerged because they have the Harbour Platyrium, and then it was the taxonomist, Professor Singh, who joined us. It was all voluntary effort, and what problems we could identify was, it was urban heat island, you can say, phenomena. The University of Mumbai is located in one of the areas that have worst air quality index and urban flooding also. So it was a collective community effort. And you can see some of the objectives. I'm not going to read out because it is just 12 minutes. What we could achieve was basically, it is a very beautiful mapping. And if you can see in this first map, these are the 5,357 trees we could geotag. And we did not just geotag the trees, but we also emerged with entire, you can say, documentation of trees in terms of tree trunk size, in terms of what kind of commercial use is there, what kind of, you can say, ecological services the trees provide. You can also see the spatial query we could very much emerge with. Another example, these two examples of spatial query. So we could identify trees on the basis of height, and we could also identify trees on the basis of what varieties these are. The most important part was that we also emerged with carbon sequestration. And you can see this table. For each tree, we calculated its carbon sequestration, the annual rate. And because of that, we could actually emerge with a kind of a position where we can basically emerge with carbon trading and also carbon, you can say, credits. This was something very important. The next part which we could achieve was we also emerged with a kind of a QR coding. So if you visit Mumbai University next time, you will definitely find the QR codes. And this was basically to engage the younger generation, the visitors, other stakeholders, teaching, non-teaching staff, where, you know, they come and then they scan the codes. In fact, one of our faculty who is residing in the campus, her school going kid, you know, worked on this project and submitted this project, and he has emerged with lot of, you can say, interest in this particular biodiversity now. So this is the result. We also emerged with a permanent, you can say, biodiversity, you can say, exhibition. We went a step further and we have also emerged with a kind of application called as a Leaf Green. And this particular Leaf Green application is available on Google, this Play Store. So anyone can download it. Here, basically, there are two parts in this application. The first part is that this particular application gives a kind of a visualization for University of Mumbai. And this particular visualization in the form of trees, the user can also run the spatial query in terms of trunk size and you can say the height. There is also information about the Mumbai University and Kalina campus, where this particular biodiversity audit was conducted. Then you will find that we have identified some 137 species of flora and a cure. So you can see these are the results. So 137 species of the flora, whatever QR code we have generated, those QR codes are there with this particular application. So there is also a facility where people can use the inbuilt QR code scanner, and you can read the information. And then you will find that this particular application also allows the user to geotag the trees, and also the user will come to know that whatever trees the user has geotagged, so those trees, what is the carbon sequestration that is annually basically done by those trees. So this is one app. Now we have also emerged with another application that is on livability. This was basically part and parcel of this ICSSR Impress project, and the project was on urban livability. And here also we have emerged with another mobile-based application. Most of the times the problem is with that people are not really aware about this particular fact that what are the different indicators that are used to know their livability. So, and many a times whenever it comes to development of benchmarks, we will find that benchmarks are developed at the city level. They are not developed at the local level. And hence, if we allow the people, so if we engage the communities in basically having developed their own benchmarks, it will be easier for planners that what is the availability of a particular facility and what is exactly the deficit, and then this will allow the communities and then the local you can say planners to emerge with a kind of, you can say, a data set, and such data sets can be given to the local bodies and they can work on those data sets, and they can basically try to emerge with better planning. So this is basically my livability application. This is again Android based application, and if you look at this my livability, so again it is available on Google Play Store, and you can clearly see you can see on my screen that this is basically the registration. And then what this app does is that this app actually allows the communities, people on their own, to collect the information about some 16, you can say, indicators. And the 16 indicators are basically, so it asks that what is available and what is expected. So it tries to basically calculate the gap between what is available and what is expected. And then you will find that such kind of a results can be generated. So, there is also visualization in the form of graph. So, and at the same time, you can also see the color code. So the user will also come to know that what is the livability index for his own area. There is also kind of a comparison available. So within this, suppose if another user is also prompting his livability index, so there also can be a kind of a comparison done. Here, we went to Kamshet area and we trained the communities. These were basically the women self-help groups, and we trained the women. And you cannot imagine that the women themselves actually conducted this particular survey. You can see basically these points, and we could also get some very interesting results out of it. And these are the links for this application. The first is Live Green app, and then My Livability application is the second application. In Kamshet, you will find that basically we went for, and there were some 20 volunteers, and you will find that those 20 volunteers were basically asked. In the process, we also trained the volunteers because they were basically not knowing that what they are being in a you can say urban area, what they deserve to get. So suppose if it is the water you can say provision, so 135 liters of water in urban area, so they were not knowing that this is basically the benchmark that is for the urban, you can say, localities. So we also trained them, we made them understand what is basically this, and then we could get very good results out of it. So what we are trying to do is that we are trying to basically train the communities by using various such kind of, you can say, mobile based applications. Right now, if at all we have to really emerge with a very strong sustainable, you can say, community approach, then we have to train the communities. And then, these communities themselves can be empowered, and they themselves can actually go for data collection, and they can also emerge with some very important, you can say, planning initiatives. And we definitely are helping them out. We have also done such kind of a surveys in slum areas also, and where we are training the communities to use geospatial technologies, specifically this ODK, which is quite, you can say, user friendly. We are also training them to transfer it to QGIS. Students and various stakeholders we are right now, we are working with. So our commitment to sustainable development is very strong, and we are also coming out with various types of, you can say, next initiatives where we are trying to use neural networks and artificial intelligence in biodiversity, in understanding biodiversity and extending biodiversity. Thank you so much for giving me this opportunity. Over to you, Professor.
Taken where the remote sensing and GIS technology are used is whenever we take optical data. Generally, in case there is a disasters recurrent in Indo-Gangetic plate, especially when you talk about UP, Bihar, West Bengal, at that point of time, you want to have a damage assessment. What is the exact damage? What is the amount that has to be settled? Because the people who are living in those plain areas are very low socio-economic backward area. So the real kind data that can provide you the real time is microwave data. So what we have done is we have taken a radar set, satellite images, then we have taken the different kinds of corrections, pre-processing, post-processing corrections we have done. And thereafter, we have classified the entire satellite images, and we have differentiated between two units because our focus area was we wanted to do offload induction simulation modeling, so then we can help the district administrator keep the same flow persist. So what is the expected area that is likely to be submerged? Because at the end of the day, the risk is high when there is a vulnerability is high. So if we can reduce vulnerability, we can reduce risk. So this microwave data was used to reduce the risk. Secondly, we also wanted to see the kind of damage that has been done to the agricultural land. So the optical data cannot provide you, it has got more than 80 to 90% of cloud cover. So we used the previous year data set of a same season where we had a highest cultivation area cultivated and sown, and then thereafter we overlaid our flood boundary with the agricultural boundary to take out the exact layers and the area, so that the proper crop insurance, because nowadays each and every parcel of land has to be done with a crop insurance. So at the end of the day, if there is a destruction to their land, that has to be provided with a compensation amount, because all the things are linked to their Aadhaar card. So the exact, because many times you will be getting false complaint or false people will be coming up, then they will also claim. So the remote sensing and GIS technology is the only technology that can certify whether there was a damage to their or his crop or not. And secondly, as a scientific domain, as a scientific personnel, if you are using a technology, always there should be come into mind why there was a damage into that particular area. The second questions comes to our mind whether this area is persistent or why did it happen in that area. So thereafter, to do such kind of data analysis, you need meteorological data. And we took TRM data, that is free of cost, tropical rainfall measuring mission. And then we took 4 months season data, that is the monsoon months data, and we geo-referenced it. They are the point data. Then we special interpolation technique was created, especially IDW. I chose it because that provided the best result. And thereafter, we wanted to see whether the problem was natural or man-made. Next slide, please. So you can see the kind of water dynamics that has happened over the period of time. So you can see what was the maximum period of time and the maximum date where the highest point of water reaches to that agricultural land, and gradually you will see the decreasing trend. So we created such kind of simulation model. Next slide, please. And this is the difference image. That what we created, we took 50 years of data set of the same month, and the rainfall of that year where there was a flood, and that led to breach in the embankment, and that created a heavy disaster in Kosi. And what we saw was that in the previous month, generally what happens in July and rainfall are the months that receive the maximum rainfall in Indo-Gangetic plain, especially in northern and southern Bihar plain. But in that year, when that it took inundation in that area, the amount of rainfall that was, because you will see that the Bihar is located in the plain area, and the entire runoff that is generated are the coming from the Tibetan plateau, Nepal. So that runoff, the entire moisture contained was very high enough in June, July itself, and that led to a heavy disaster in August. And that was the reason that it was the rainfall that created a heavy disaster. Please, next slide. And there was another study that we have done on the same area, because when as an administrator, whenever you are going as a planner, you have to see which blocks, which tehsil, what is the watershed area that has to be prioritized. So what as a geospatial expert, we provided a solution. The solution was we took a multi-temporal data sets ranging from AWIV's data set of 2008, 2001, and historical data sets from 90, because from 1972 onwards, we have got the satellite series available with us. So we took all those data sets and we classified the satellite images, and we created the, because our prime focus was, if you go to the Bihar, flood itself is a disaster, but the other disaster is post flood. The water stays throughout there in that portion of land, gradually known as a waterlogged area. So you have got two kinds of water logging that happens in northern Bihar plain. We have got a permanent, another one is seasonal. Seasonal is still a disaster because the sowing reason is gone. That's why the cultivators doesn't grow any crop. So that is the wasteland category that is being created because of flood. So we took all these data sets together to create a combined hazard map, because we took a flood data of 20 years, and then we correlated the flood data with the water logging data, whether this both the data sets are common in nature or they are different. If they are different, then we'll be taking the different kinds of geology, geomorphology, and the different structural maps in order to understand what is the changing dynamics. But if there is a disaster, that must have a risk, and for that we created the vulnerability. And for vulnerability, we took all the socio-economic parameters ranging from population density, because where the population will be high, in case you have got a wasteland or you have got a flood, you will have high disaster. In the same way, the sex ratio we took, because where the sex ratio is high, if the cultivators, agricultural laborers, because they will be losing their job. So the districts that are having the highest number of agricultural laborers or migrant laborers, they were given the range. In the same way, children's in the age group 0 to 6 and the old age portion, because they are highly susceptible in case a disaster happens. And finally, literates, because a person who is more literate has got a maximum understanding to on literates. And all these layers were given the various kinds of we have done different kinds of modeling. We provided rates to each and every individual layers, and finally we created a flood water logging risk map. Please, next slide. So these are the layers that we took, and we created the district wise vulnerability hazard for each and every districts of the northern Bihar plain, because they are the districts having the highest population in terms of low land holding capacity, and the migration is very high. And that was a part of our project. Next, please. This is the socio-economic vulnerability maps that we created. Next, please. We provided all this with different kinds of EHP weighted rankings were provided. And finally, we created a socio-economic vulnerability map. And finally, we created a risk map. And this is my last study. And with this, I'll be ending up. In the same way, we wanted to see that if this is a flood, whether the flood is natural or the water logging that is creating is man-made or natural, or whether the different kinds of canal irrigation system what was introduced in India that is leading to seepage and gradually the soil salinity, and it will just like in INGAP, if you go in Rajasthan, maximum area has been converted into soil salinity. The same thing we have noticed in Indo-Gangetic plains, especially in Eastern Gangetic plains, where the construction of canal, where the areas which has got the maximum saline soil salinity land, as well as the wetlands were very high, and they were the areas that we are facing the heavy floods in those areas. And for creation of, because whenever you see, we have taken a lot of data sets ranging from soil data from the National Bureau of Soil Sciences and Land Use Planning, temperature data, precipitation data from Central Groundwater Board, whether it is related to water quality parameters. So you can see that multiple layers can be brought together into a single dimension, and the only solution today that can be provided is your geospatial technology. And all these layers were created to create a spatial decision support system where we can highlight the areas where we can go for different kinds of reclamation measures, where we can go for various kinds of watershed construction of check dam, nala bunds, in order to store water in case there is excessive runoff in that area. Next, please. Next slide, please. So you can see this is the total distribution of the permanent. The black colors are the permanent water logging area. So you can see this entire area, nearly you will see the entire area is covered with this wasteland. Next, please. And if you see, you will be seeing this is the entire river system that drains into Bihar and meets into Ganges. So we generally see Bihar, UP and West Bengal are generally flooded. Why? Because the rivers that are coming are from Tibetan Plateau. So whenever you do any kind of management, it cannot be on the basis of state boundary or national boundary. But what we do is we generally focus to our national and state boundaries. So whenever there is excessive runoff of coming up. If you see the Kosi and Kamla Balan, especially Budi Kanak, the upper watershed is especially 5 or 6 times bigger in size than the lower watershed, and that is beyond the carrying capacity of the river, and that leads to heavy siltation in this area. And because of that, you can see a difference in topography. Slope is another factor, apart from that structural measures that creates a heavy disasters in the low-lying area, and that is recurrent in this part of the world. Next, please. So this is again, we have taken to see the spatio-temporal dynamics, key, whether the flood dynamics, waterlogging and rainfall has any connection. So what we found that the flood has a positive correlation with the wetlands, wasteland, because they were those areas where we had a permanent waterlogging. They were those areas where we had a maximum soil salinity. So we have got a correlation with it, and we have taken for mountain front and plain front. We divided into 2 portions. Next, please. And these are the different layers. We're using the satellite images because the topography is plain. So we use the various visual interpretation. We use the ASTER GDM data.
About the climate changes. So climate changes and its impact. So basically we can say here, if you are working on that one, then we found that climate changes are basically covering in 2 bases types of challenges. One is that is decline in glacier extent and their thickness, and due to that decline in glacier extent, what happens that the thickness is going to reduce day by day, and after that there is a, we can say, damage, or we can say burst in a glacier. So that is one main challenge, and the indicators for this one, we can say depletion indices for mass balance of glacier. Then we have to find the shifts in composition of total precipitation from snowfall to rainfall, and then we found that the monsoon onset, duration, and the intensity. These are the main indicators by which we can find out that what are the challenges in that day. The another challenge is that one decline in seasonal snowpack extent and weather patterns. So again, the thing is that one, that as we know that the rate of snowfall is changing year by year. So that is again one challenge, and in that way it impacts on the glacier melt related risk. And due to that one, for that one, we found the indicators are related to that growth in number of extent of glaciers, lakes, then occurrences of glacier lakes, outbursts, floods, etc. These are the main indicators. So if we say then as we can say, our glacial bursts, these are basically we are facing a cascading risk. And if we see from last few years, or we can say from decades, we found there is a different type of disaster due to glacier. As we know, in 2013, there is a glacier outburst and Everest flow disaster that is in Kedarnath region, and due to that, we found number of they are Then again, in last year, 2021, there is again a flash flood event was occurred due to the glacier burst in the Nanda Devi glacier. Again, we found there is a loss of life damage, as well as we have that damage of that infrastructure and etc. In that case, we can say if we are focusing on Nanda Devi, then we found that the glacier that is triggered in a landslide, avalanche, and flash floods in the
I think he has again lost it, Dr. Ramshankar. Yeah.
Yeah, maybe. I think he's back now. Hello. Dr. Srivastava?
Yes, sir.
Yeah.
Yeah, I'm. Screen is visible, sir.
Yeah, visible. I think considering that the instability in your internet connection, no, maybe if you can go to your major contributions, like the conclusions, no, then we can wind up.
Yes, sir. Because that. Yeah, something happened. Yeah, something. Yes.
Yeah, maybe you can go to the last few slides and tell about your takeaway points.
It is going to. So, okay, basically the thing is that one here we. Yes, sure, sir. So, as Dr. Shima, Dr. Aparna, they focus that we have a number of sustainable development goals. So here in our work we have focused about the climate actions related to sustainable goals, and in that focus we found that we have to make a few urgent actions to combat the climate changes and its impacts. And these are we have to make the strengthen in the residency, as we found that due to that damages, what happens due to debris covered, what happens that the glacier thickness is going to be less, and then there is a chance that they can broke anytime. So we have to work on that one. We have to work on the strengthen. We have to integrate climate change measures into the national policies. We have to make the policies that how we are going to change a few measures. We have to take in care that how the climate is going to be changes and what are their impact on the glaciers. Then we have to make the education, we have to make the awareness that for humans and institutional to make the to control the climate changes and its mitigation, its adaptation, etc. All these things come for the sustainable development goals. Now, as up to now in our study, we have basically worked about the geospatial technology for monitoring the environmental changes. So in that system, we can say we have found the GeoWeb as a hazard assessment for early warning system. So in that system, that it is not possible for a human that we have to go lively one-to-one location at each and every glacier and to find out, to measure that what is its impact, what is the change in their volume, their area, etc. So for that one, the GIS as well as remote sensing data, they plays a major role. So in that sense, as we know that nowadays satellites, we are getting a more high-end, very high resolution of data, and based on that one, we can find out each and every changes on the glacier surfaces. So in
at the level of the country, and how it can be used for managing the complete elections, or what are the different aspects of this which you think are there, which can be used by the society for better management of the entire system.
So basically, entire data using the open source software tool. The database we are keeping in the PostGIS, and again the front end we are developing with the help of open layers. So these two, and of course in between we are using Geo server, which is also again an open source tool. And the tools and technology which we are using to develop this application definitely is scaled up, because there are other portals like Google. They are also using similar kind of technology. It is only will be an issue of implementing the multiple instances of GeoServer to handle the data. As far as the handling the data is concerned, it can definitely be kept in different smaller sections and segments and can be handled. Of course, we have to plan it carefully, and we have to just dig in deeper how exactly it will be done, but it is definitely possible to be done using the technology which is being employed, or which is being used now in our application. And we can definitely think on these lines.
Right, thank you. The voice was cracking, but I think you made a lot of sense, and this system, I think in case it is scaled up, it will definitely be useful at a much higher level. Professor Raj and Dr. Shamita, you can also budge in case you have a question. I'll move on to this thing. In case you have a question, please ask now.
Yeah, sure. No, Professor. Yeah, we can move on to the next.
Right. So, Professor Ramya, you presented a very good work on.
Professor Tiwari, yeah, Professor Ramya also left. She just messaged me. She had to leave. Yeah.
Fine. No problem. Then Sumit Sen ji, I would request you to highlight how your work can be scaled up and can be considered for presenting at the UNGWIC.
Thank you, Dr. Tiwari. Are you able to hear me?
Yes.
So our work is not really work, it's the vision of the GIC Hub. And we have just recently been funded, so we are setting up our team. But I think what I presented is relevant to the education group, which is headed by Abbas, Professor Abbas and the team. And I think in that context, I can try to develop, how education or capacity building can, be sustainable and be scaled up. Yes, that I would try to present. Yes.
Sumit, yeah, can I ask?
Yeah,
Please,
please.
So actually, just to benefit the others also, who are listening here. So now you mentioned about hub and spoke model. So now I assume that our IIT Bombay GIS will act as a hub, and so whether the spokes will be at different institutes across India or will it be within IIT Bombay? So you can tell about the vision, like how the GIC hub will work, how it will collaborate with other institutes, education institutes. So it will help the other people also to get participated.
Correct. So
you are muted, Sumit.
Is going to not only work as a hub and spoke, but actually enabling mini hubs, which over the next 5 years will become hubs by themselves. How we will collaborate with them? First, we will have joint projects. We have visiting scholar programs by which faculty members and researchers from other institutes can spend time in IIT. In one of the many projects that we have here. And also we will have regular workshops, summer schools and winter schools that will be announced. And in fact, every year we will have one summer and one winter school. So the idea is to engage in continuous capacity building and in a multidisciplinary context. So Dr. Raj over here is a specialist of expert in cryosphere. In fact, many organizations would like to work with him, but the hub and spoke model will provide scholars the opportunity to work in some of the projects that the GIC hub will be managing. And of course, last but not least, we also have the entrepreneurship unit by which we will try to harness the entrepreneurs, young innovators, to build their own companies and startups in the geospatial technology domain. So yeah, we look forward engaging very closely with other academia, government agencies, non-government agencies who develop this the capacity building initiative across the hub and spoke model.
Right. Thank you, Dr. Sumit. I think this is quite informative. The different activities which will be undertaken at the GIS hub or GISE hub. So thank you for the information. Now I request Dr. Aparna Phatke. You presented a very wonderful idea of livability index. Can you please highlight a bit on about that? How this can be made use by the society for the betterment, or how different districts can probably be educated to make use of this.
Yes, sir. Thank you so much, sir. Am I audible, sir? Because I'm traveling back home. Am I audible?
Yes, you are audible.
Yeah. So basically what we did was that we developed, first we conducted the survey on the basis of various indicators, and then we then selected 16 indicators for this particular mobile application. Now in the process, what I found is that there is national indicator framework for measuring the livability. But then, there have been several, because national indicator framework is basically compiling information from various departments, and there is no such mechanism. So whatever indicators are there, on the basis of that, there is a creation of benchmarks, service benchmarks. But when it comes to an individual area, you will find that these benchmarks are not of much use because the geographical conditions, they differ. And then that is the reason we thought, and in many communities, like say for example, when it comes to Mumbai, and suppose if we want to have a survey, and if these are the officials going for the survey, many a times there is a resistance from the communities, say slums, for example. They always have a fear that there is something going on, and they may be vacated and they may be displaced from this place and all. So what we thought is that whenever now we are trying to connect the communities, and I think hereafter communities are going to be the central, you can say, focus of all kinds of developments with the decentralization and 74th constitutional amendments and all. So what we thought that let us try to train the communities. And so so we went to Kamshet and we tried to train these women through one particular organization, and these are basically the women self-help groups. So these are the SHGs, and to our surprise, they picked up quickly because they were having smartphones. And then we asked them that whether you can do this survey. So if at all, with the help of non-governmental organizations, if the communities are trained, they can actually emerge with their own, you can say, benchmarks. And then, if they are given to, because now with the 74th constitutional amendment, now even there is a lot of scope given for the village development plans. And one of my colleagues, my co-pilot, Dr. Praveen Pune, he has recently worked with one village development plan. So if at all we allow the communities, now even there is one more, you can say, scheme at level, where actually 1 lakh rupees given for diversity mapping. And also since these sensors, some you can say, if at all we can train communities, so these could be educational institutions. So in Mumbai University, what we have train our institutions that are affiliated to university. So kind of, you can say, a collection of data. This data can be for this project communities, but now we are contacting say BMC officials also for this, whether we can have such kind of stakeholders involved in this. Recently, one community in Manko, this so basically slum, can collect the data. Many times collecting real data is a big you can see issue, and that I could also see when I was trying to go through the entire literature of this national indicator, and I could see that this particular framework is also totally relying upon the data.
Right. Thank you, Dr. Aparna. I think your voice is breaking. The idea
that is coming from various ministries. It's a real problem.
Dr. Aparna, thank you. Your voice is breaking, but I think this is one of the good ideas that you are working on. And if it is optimized and used by different districts, it will definitely do a lot of good to them. But because of shortage of time, I would quickly move on to the next speaker, Dr. Suraj Kumar Singh. Dr. Suraj, Dr. Suraj, you are right now also you are in field. आप क्या कर रहे हैं अभी समय फील्ड में?
सर अभी हम लोग फॉरेस्ट फायर के कुछ स्टडीज के लिए आए थे अपन.
So can you highlight some of your work which you think can be scaled up and they can be used by different states or even at the lower levels, at the district levels? So what are some of the works which you think can easily be taken up by them?
Yes, sir, we have got a lot of work because it was 15 minutes time. That's why I didn't showcase many. Only the water resource I took as a theme and I showcased. Otherwise, we have got a good chunk of papers that are published, accepted in high reputed journals, and we can showcase it. They are good models that we have developed.
Any specific or any particular thing which somebody at the state level or at the district level is using?
Right now, sir, whatever models what we have generated is we have handed over to different IFS officer, district magistrates, but we have never have a follow-up of the reports and the publications that we have published. I can't comment on its generosity, whether they have acted on our reports or not, but we have submitted all the reports to them from time to time.
Right. Thank you, Dr. Suraj.
Yes, sir. Thanks a lot.
Now, finally, I come to Dr. Mohit Srivastava. Mohit Srivastava, you are working on a very important area of work related to disaster, but you are not there. Are you there?
No, sir. I think he is not there.
He is not there.
Yeah, his connection is also was unstable.
Yes. Yes. Overall, in my appreciation, I think everyone gave a very good presentation. People seem to have been working. They have been working, and they have done a great deal of work. And from my side, I would say that they should all continue working hard, making this geospatial science and technology. Bringing it down to the level of the state, even to the level of the individuals, where they can make use of it and utilize it in their daily lives. Dr. Samita, with this, I thank everyone. Back to you.
Ma'am, you are muted.
Thank you so much, Dr. Tiwari and Dr. Ramasankaran for chairing and steering this session and teasing out the good ideas from the participants. I also thank all the panelists. It's just one observation that I would like to make before we conclude. Having looked at the government sessions in the morning and the industry later in the day, in the afternoon, I feel that as academia, we probably need to gear up to meet the new challenges, because when you look at those presentations, they're more on technology development, use of WebGIS, sensors, AI, ML, completely different kinds of structured, unstructured data sources. And maybe one needs to look back again at our own curriculum to see how universities can become the nursery for training the manpower required to meet these new challenges and in this new era, which really offers a lot of opportunity. So with that, I really thank all of you for participating in these sessions.